All right, and let's take a look at that lab data. So again, this is in the lab notes section of Canvas. So this is your sample data. So we're only doing 2 trials, and we only really do 2 trials in class. This other is in case you had some problems and you had to redo it. But you have an initial burette reading and a final burette reading. Notice, just like in the video, your burette's always read to 2 digits after the decimal. For the grams of KHP reacted, I put it right down here on the bottom. So what I have students do in lab is to first weigh their flask and then come back into the lab room to add the KHP. And the reason is so that we don't have a mess in the balance room. So you weigh your flask empty and then you weigh it with KHP, which is a solid acid. And so the difference of these two, you're going to calculate right over here. But I want to talk to you a little bit about the lab before we go over the calculations. But any questions so far? Okay, so let's talk about that lab a little bit more. So again, we're on day 2. So we just watched how to read a burette and titration technique using a burette. So if you didn't join us for class, please watch those from the Lab 8 playlist. And I'm hoping that everybody will watch that Lab 8 demo with Dr. DA. That's about a 30-minute video, but it's a very, very good one. I'm trying hard to convince you to watch it. All right, so we did all of this last class. All right, and we are on the procedure for Part B. So what would have happened in this procedure is you would have brought me up a test tube with your name on it and possibly a stopper on there, and I would have given you enough for 2 trials. So then I would have sent you into the balance room to weigh out 2 flasks. You would come back to your bench top, and you would put half into each flask. Then you'd go back and weigh it again. So those are the measurements I just showed you. Then at your bench top, you would need to dissolve everything. So here you're going to dissolve in distilled water. And it would be about 50 milliliters of distilled water. And the reason there's a little squiggle next to it is it's approximately 50 milliliters. Adding more water does not change the amount of acid because the acid was already weighed out into the solid. Then you have KOH, and this is the same KOH you would have created in day 1. So day 1, I had you measure, or I guess not actually measure, but I had you calculate how much KOH you would have added and how much water you would have added in 1A. That would have gone into a glass bottle. And today, and also in Lab 9, you would be using that glass bottle for your titration. The idea of Part B is to standardize it. So it was only approximately 0.5 molar KOH. We never give you exactly 0.5 molar, and there's a reason for that. And the reason is that we want everybody's to be just a little bit different. And so we want you to find your own molarity, just like you would if you were working in the stockroom or working in pretty much any chemistry lab. And so what you're doing today is that standardization of KOH, the one we talked about in lecture. So your KOH solution, the one that would be in the glass bottle, you would be filling that into the burette, of course, after washing it, just like they showed you in the video. You'd make sure there were no bubbles in there. And your KHP, which is at this point dissolved, you would add 3 to 4 drops of our indicator phenolphthalein. And we talked about phenolphthalein with the last lab. You got to not play with it in person, but see some videos on it. It says here 3 to 4 drops, but it really works well. So 1 to 2 drops is plenty of the phenolphthalein. In this lab, the most common mistake is people forget to add the phenolphthalein. So they're titrating. They got 50, 60 milliliters of base in there, and suddenly they're like, hey, it's not turning pink. Did we do something wrong? And then they add a drop of phenolphthalein and it goes bright pink. So that's the most common mistake in here. And so it is helpful to have a white paper underneath so you can see just the beginnings of the pink. We want it as light pink as possible. And that's what they talk about here, a very faint purple or pink, just like you saw in that video. All right. And before returning your burette, you would have rinsed it 3 times with distilled water for me. And we have a clipboard that has pH paper, and I would have made you bring it up to me and touch it to distill the burette to the pH paper, and if it had turned colors, I would have sent you back to the sink to wash it again. For most people that doesn't happen. 3 times is a pretty good rinse. So in a nutshell, that is your lab. So I know that's not the same as doing it in person, but any questions with what you would have done in that lab? All right, for those of you who are thinking, wow, that's not nearly enough, I really want all the gory details of that lab, and I encourage you to do so. I highly recommend that you check out that video. Let me just show you a little bit of what that video would look like. All right. So just to try to encourage you to watch it, Dr. DA talks about 5 or 10 minutes about acid-base titrations. And then he's going to show you exactly what happens in this lab. He even does it with his goggles on. Like so. So that's me again encouraging you. I know it's 30 minutes of your life, but it's 30 minutes of your life well spent. All right. All right, so questions about anything from the lab itself? All right, so I want to go on and talk about the calculations. So we talked about trials 3, 4, and 5 being extra. So those will be blank for us. If you were in the lab and you made a mistake on one trial, then you can use that. So trials 1 and 2, or I'm sorry, initial burette and final burette. So to find your total KOH delivered, it's the difference between those two. So it is a subtraction between the final minus the initial, and it should be a positive number. So if for some reason you did, you subtracted them in the wrong order and you got a negative number, make sure you make it positive because we're talking about milliliters. They should always be positive. All right, next up is grams of KHP reacted. And that's where you're going to take the difference between the mass of the empty flask and the mass of the flask plus KHP. And you're going to place that with the grams of KHP reacted, and you're going to have a number for trial 1 and then another number for trial 2 because you have data for both trial 1 and trial 2. All right, so next up, moles of KHP titrated. So here, you're doing a grams to moles conversion. So right up here, you have found the grams. Now you're going to use the molar mass, which I'm so nice, I've put it right here on the side. And the reason I put it on the side is because you have to be careful. P is not phosphorus. P stands for phthalate. So this P right here stands for this whole big old chunk. So your molar mass is 204.22 grams per mole. You're going to use that molar mass to go from grams to moles. So you'll do that both for trial 1 and for trial 2. So any questions on anything so far with those calculations? Okay, so next up, moles of KOH delivered. So now we need to do a mole ratio conversion between KHP and KOH. And here is our chemical equation. This is a balanced chemical equation. All right, so that is a balanced chemical equation. So it is a 1-to-1 relationship between our KHP and our KOH. So what that means is however many moles of KHP you're titrated, you should have the same number of moles of KOH, because again, it's a 1-to-1 relationship. Then for the molarity of your KOH, molarity is moles per liter. So you're going to take the moles of KOH that you found right above here, and you're going to divide it by the liters of KOH used. So you know total milliliters KOH delivered, but you need to convert that into liters. And that's where you're going to get the liters for moles per liter. And finally, at the end, we want you to average them. It's kind of weird the way this is written, but we want you to put your answer, the average, right over here. So average, add both together, and then divide by 2. Okay, so there are also some post-lab discussion questions, but any questions on anything here so far? Okay, so just to remind you one more time, your sample data, which you see right over here, I want you to copy all of this onto your lab sheet. If you don't have that lab sheet, go ahead and put it on a piece of paper. And then this you can find in the lab notes section on Canvas. All right, so let's go on and talk about those post-lab discussion questions. All right, so the very first one, I've written out your chemical equation for you, but notice it is not balanced. You're going to need to balance it. So it says calculate the volume of 0.450 molar barium hydroxide, which will be needed to neutralize 46.00 milliliters of 0.252 molar HCl. So this is very similar to the titration and the solution stoichiometry problems that we've done in class. So I know those were a while ago, so let's just take a look at those. So if you go back to your chapter 4, pull it up. All right, it is not coming up. Let me try another way. Sorry about that. I don't know why it didn't come up. I must have been misspelling a word. Here is your solution stoichiometry problem. So this is slide number 20 in chapter 4. And here was a problem where we had to find the volume of Ki that needed to react with our lead nitrate. So again, this is your solution stoichiometry problem, slide 20 on chapter 4. This will help you out with that first problem in the lab, but don't forget to balance that equation. All right, for part B, find the molar concentration. That is the same as molarity for sulfuric acid solution. And here we have 35.00 milliliters of that sulfuric acid neutralizes 25 milliliters of 0.320 molar NaOH. All right, and below it says be careful, sulfuric acid is diprotic. You do need a balanced chemical equation for this. And just to remind you of when we did this in lecture, I know it seems like forever ago. There we go, comes right up. It'll come up. Titration. There we go. All right, so here we're at slide number 52 from chapter 4. So this is a titration problem, just like you're going to see on that 1B from your post-lab discussion questions. And this shows you how to find that molarity. All right, so any questions so far from either the calculations from the lab or the post-lab discussion questions? All right, so next up, 1C is a little bit of a challenge problem, but I know you can do it. So it says find the molarity of water. And so here it says, hint, the density of water at 30 degrees Celsius is 0.9957. So that's just a more precise one than the 1 gram per milliliter we've been using. Please use the one that they give you in the problem. And my hint to you is assume 1 liter of water. So start with assuming you have 1 liter of water. From there, you can find your grams of water. Once you have your grams, you can find your moles. So I believe in you. You all can do that. And again, if you want help on that problem, I am here till 9:45 tonight. All right, so next up, 1D. Here we have 15 milliliters of a sample solution of sulfuric acid, H2SO4, of an unknown concentration. It's been titrated with 0.3200 normal NaOH, and I've marked on here that that is the same as molarity, and I'm going to show you why in just a moment. Now the titration required 21.30 milliliters of base, and we're assuming that the acid was completely neutralized. All right, there's different ways to solve this, but my advice is do the second part first. And I know that sounds weird, but that is the one that we've been practicing, finding the molarity of an acid given all this information about the base. So that one should be similar to what you're doing right up here with B. So B, you're finding molarity, and D, part 2, you're also finding molarity. Then I'm going to ask you to convert from molarity into normality. I'm going to talk a bit about it here, and then we'll talk more about it later. But again, my recommendation, solve for molarity first, then find your normality. And what normality is how many moles of hydrogen ion per liter. So rather than talk about moles of acid overall, we'll talk about the moles of hydrogen ion. And it looks like we got a question. Does temperature have anything to do with, I'm assuming instead of 3 you mean C, and it doesn't. You're not actually going to use that 30 degrees Celsius. It's just given as a reference temperature. But good question. So Jervin's question was about C right here, and he was asking if you needed to use the 30 degrees, and the answer is no, you don't. Oops, you don't need that 30 degrees. Okay. All right, so let's talk about that normality. So the difference again between molarity and normality is molarity is moles of acid and normality is moles of hydrogen. So why we care about this is if you have something like sulfuric acid, you essentially have twice as much power in your acid because sulfuric acid is H2SO4. That 2 right there means there's twice as much hydrogen ion. It can neutralize twice as much base. So if we really want to know essentially how much acid is in your acid, we really want to talk about normality rather than molarity. So for acids, the normality will be moles of hydrogen per liter, and for bases, it would be moles of OH minus per liter. So let's take a look at a couple examples. So the first example I have here is with sulfuric acid. So if we want to convert this from moles of acid into moles of hydrogen, we could say that 3 molar is 3 moles per every 1 liter. Now I use the conversion for every 1 mole of sulfuric acid. Right up here, we get 2 moles of hydrogen, which is this right here. So it actually is 6 moles of hydrogen ion per liter. So instead of being 3 molar, we could call it 6 normal. So it is twice as strong as we thought it was for molarity, and that is because of the 2 hydrogen right here. So this allows us to compare our sulfuric acid to something like HCl. So HCl, if I had 3 molar HCl, it would also be 3 normal. So essentially, we're going to get 3 moles of acid out of that HCl, 3 moles of hydrogen ion. But if I had 3 molar H2SO4, it's going to be 6 normal H2SO4. So in other words, we can neutralize twice as much base with the sulfuric acid because of the 2 right here than we could with the HCl. So I'm going to show you some more examples. But any questions so far? Oh, so I see like a concentration. So normality is a different form of concentration. It's talking about the concentration of the hydrogen ion only, not the whole H2SO4. Good question. So I would have to look up to see which one of those 2 is stronger. But what we do know is I guess in the sense that it releases more hydrogen ion. I guess I would have to look up to tell you for sure, but it does release more hydrogen ion, and so using that definition, I guess I would want to look it up before I answer that specifically because sometimes we talk about stronger acids as ones that have a more complete dissociation, and both HCl and H2SO4 are close to 100%, so I'd have to see which one's closer to 100%. But it does release more hydrogen ion. In fact, it releases twice as much hydrogen ion for every mole of acid. So sorry, Amber, that wasn't probably as clear of an answer as you were hoping for. All right, but other questions so far? All right. So what we're going to do to find our normality is we're going to take molarity times the number of hydrogen for our acids. So for instance, if I had a 2 molar phosphoric acid, which has 3 hydrogen that can react with our base, then I would do 2 times 3, and I would get 6 normal for that phosphoric acid. So any questions on that phosphoric acid, why it's both 2 molar and it's 6 normal? Because the normality includes how many hydrogen could come off. All right, so next up, let's take a look at that HCl. So 5 molar HCl is still 5 normal because we're multiplying it times how many hydrogen can come off. So 5 times 1 is still 5. So any questions about that HCl on why the molarity and the normality are the same? Okay, so next up is that sulfuric acid. So it has 2 hydrogen. So if it was 7 molar, we would then multiply that by 2 to give us 14 normal. So any questions on our acids for converting between molarity and normality? Good question. So yes, we only use it for acids and bases. All right, so other questions? Just to give you an idea of how it would work for a base, let's say that you had barium hydroxide. Oops. And let's say you had 2 molar barium hydroxide. If you wanted to find the normality of it, then I would say 2 molar, and I would multiply that 2 molar by 2 hydroxides. And that comes from the 2 right over here. So for bases, we use the hydroxides, and it would become 4 normal. So any questions on what I just did for that barium hydroxide? All right, so I want to do one more, and that is the one that we were looking at way back here. All right, so here was NaOH, and I crossed out that normality and wrote molarity because they are the same, but they are the same only for things like NaOH or HCl. So let's say I have, I'm going to say 5 molar NaOH. So for 5 molar NaOH, I'm going to say 5 molar times 1 hydroxide. That's because there's only one of these hydroxides. So it is 5 normal NaOH. And that's why in the problem I said I crossed out the normality and I put molarity, because it is the same for something like NaOH that has only 1 hydroxide, or HCl that has only 1 hydrogen. All right, so questions on anything here? Okay, so I've updated this little section on converting between molarity and normality, so I'm going to re-upload the Lab 8 notes. For those of you who are interested, if you were doing this, I would have this up on the screen. So, excellent. All right, so in lab, we actually asked you to only rinse once with the KOH solution, and that was to conserve it because you need to use it in Lab 8, and you would also need to use it in Lab 9. And the very sad thing is if you run out, you can't, I'm not going to say you can't do Lab 9, but you would have to borrow KOH from another group, and that becomes quite a pain because then you have to figure out the molarity of both. So that's why in lab, for Lab 8, I would have told you only to rinse it once with KOH. And then here are all the other instructions that the videos gave you with the star next to clearing bubbles, because that causes problems if you forget to clear those bubbles. All right, so that is our Lab 8. Any questions on anything with the Lab 8? So I'm again going to try to convince you to watch Dr. DA's demo of this lab. It's a great demo. It's about 30 minutes long, but everybody has access to Canvas, so you should all have access to the Lab 8 sample data. And then you can, I'm hoping that most of you have your labs with you, your lab notebook. so that you can write it in directly to these pages. But again, if you don't, then copy that data onto a piece of paper and you can do it from there. So any questions on anything from that Lab 8 or anything from lecture? Okay, so I will be here till 9:45. If you have any questions, you're welcome to leave and come back or just stay and hang out. Thank you all for coming. I will update that video that we made on Monday that I forgot to turn on the microphone for. I apologize. I will update that. And I know a few of you are going to be working all weekend, so I'm going to do my best to update that tomorrow. All right, so thank you for coming. All right, so have a wonderful evening. And hopefully I'll see you all on Monday.